In this example, we're going to multiply two different numbers by exploiting the idea of scientific notation. So this problem is asking us to multiply 0.000034 times 1800. And already that first number is so difficult to say without the use of scientific notation. So what we're going to do in the first step is just convert both of these to scientific notation. So, looking at the first one, 0.000034, how many times do we have to move the decimal place? We have to move it 1, 2, 3, 4, 5 times to the right. So it must be 5 decimal places smaller than 3.4. Therefore, this one becomes 3.4 times 10 to the negative 5. And for 1800, we've got to move the decimal place 3 places to the left. So this is going to go to 1.8 times 10 to the 3. So now, step 2 is rewrite. Now I have 1.8 times 10 to the 3 times 3.4 times 10 to the negative 5. And one awesome property about multiplication is that it is commutative, meaning I basically have 4 terms here. 1, 2, 3, 4. They are all being multiplied together, and I am allowed to change the order of any of these numbers as long as they're all being multiplied. This means is I can rewrite it to say something totally different, but it still represents the same thing. I can rewrite it as 1.8 times 3.4 times 10 to the 3 times 10 to the negative 5. There's nothing wrong with me doing this. And I can take this a bit further now, because these two I can multiply 1.8 times 3.4, and these two I can multiply separately. And 10 to the 3 times 10 to the negative 5, I can multiply by using exponent rules. And basically, this right side can just be 10 to the 3 minus 5. Because if you have two numbers multiplied by each other that have the same base, you can add their exponents. So I did 3 plus negative 5 to get this part here. And now, for the left side, I just do 1.8 times 3.4. So I get 6.12 times 10 to the 3 minus 5. Or, I get 6.12 times 10 to the negative 2. But I am not done yet, because I still need to think about significant figures here. If you notice that my original numbers up here, the 3, 4 here only has 2 significant figures. Thus, my final answer should only have 2 significant figures. So I'm going to round to the nearest tenth in this number here. So what I'm going to be left with is 6.1 times 10 to the negative 2. And that is the final answer.